Sanbonani Abafundi, welcome back, and today we are starting our study of calculus, which is super exciting, a really nice topic, one we know you're going to enjoy. So without any further fuss, let's dive straight in. Okay, so we're going to go straight to our workbook, and differential calculus, there are two types of calculus. One's called integral calculus, we don't do that at school, but differential calculus is all about the study of rates of change. Okay, and we've already encountered a rate of change. A gradient is a rate of change. We're looking at how does y change for a given change in x. Okay, and so let's take a look at a gradient of, for example, 2 over 5. Okay, that means that as we run across 5, we rise by 2. Okay, so basically a line like this black line I'm about to draw, like that. Okay, that is a gradient of 2 over 5. A gradient of -3, which we could write as a fraction, -3 over 1, means that we're going to drop down 3 in the time that we run across 1. All right, and notice it doesn't matter where we start. All right, if I start over here and I drop down 3 and I run across 1, I get two identical lines in terms of their direction. Okay, they are parallel. Okay, there's the formula that we've used previously for gradient. It's our two y values subtracted divided by our corresponding x values subtracted. It's rise over run. But remember that a line like this has got a negative gradient because as we move from left to right, our y is decreasing. So our change in y is negative. Contrast that with this line, which is going uphill as we move from left to right, and our change in y is positive. Remember, because we're moving from left to right, our change in x is always positive. Over here and over here, change in x is always positive. Okay, right, so let's now we've spoken a little bit about that already. Let's just do some examples here, determining gradients. Okay, this is just revision, it's just practice. What we like to do is we like to just put these points roughly in the right place. So if 2, 3 is over there, then 7, 19 is to the right and above. And the only reason it's helpful to draw a rough sketch is straight away I can see that this line is going to have a positive gradient. Okay, the gradient of this line, okay, is just going to be how much has it risen. Okay, now from 3 to 19, remember rise has got to do with y values. It's risen 16, and from 2 to 7 it's run across 5. Okay, we can use the formula 19 minus 3 over 7 minus 2. Okay, let's do another one. 3 negative 2, suppose 3 negative 2 is over here somewhere. Then 5 negative 9 will actually be to the right and below. This line has got a negative gradient. Okay, something like that. It's dropping down 11. So the rise is actually negative 11. Remember that the run is always positive. It's going from, sorry, not 11 at all. From -2 to -9, it's dropping down 7. My apologies. All right, it's running across 2. Okay, there's our gradient. Let's do another one. -2, 6. In fact, why don't you pause the video briefly and you try, and then we'll see how you went. Okay, so -2, 6 is over here. And 5 negative 1. 5 negative 1 is actually somewhere down here. This one also has a negative gradient. Okay, we don't even need to draw the line in, but let's draw it in. All right, we are dropping 7. So our rise is going to be -7. We're running across by 7 as well. So in fact, this line's got a gradient of -1. Okay, and then 3, 1, 3 negative 1, and 5 3. Let's have a look. 3 negative 1 and and 5, 3. 5, 3 is to the right and above. So this line is going to have a positive gradient. Okay, this last one is going to have a gradient. We're rising 4 in the time that we're running across 2. Now we can write that as 2, right? It's often more useful to think of a gradient as a fraction, okay? Because we can see that it's rising 2 in the time that it runs across 1. Now we're going to look at some sort of real-world examples of rates of change. So here we've got an athlete, and this shows the distance that they've covered in a certain time. Okay, so the question says, what was his average rate of change, okay, over the whole time? Okay, so the average rate of change of distance with respect to time. So what we're going to do here is we're going to look at this point over here and this point over here. All right, and we're basically going to find the gradient of this straight line. Okay, that will be the average rate of change. So actually, how far have we risen? Well, 160 meters. Just hoping I'm reading this right across correctly. Yeah, 160 over 30. All right, and that will be an average speed. It's a rate of change of distance with respect to time. All right. This should say of distance. We call that speed, so it'll be like 5 1/3, and that is meters per second. We write it like that, meters per second. Okay. During what time interval was he going the fastest, and how fast was that? Okay, so now we need to look at where is the graph the steepest. Okay, and the graph is the steepest on this piece over here. All right, between 10 seconds and 16 seconds. So 10 to 16 seconds. 10 seconds to 16 seconds. And the speed, all right, at 10 seconds he had covered 20 meters, but by 16 seconds he had covered 100 meters. So the speed would be 80 meters over 6. All right, 80 over 6. This person is ridiculously fast. Okay, 80 over 6 is the same as 20 over 3. It's the same as 6 2/3 meters per second. Okay, when was he stationary? Well, when we're stationary, the distance is not changing while the time changes. So that was over here from 5 seconds to 10 seconds. Okay, from 5 seconds to 10 seconds. Okay, what was his speed at 20 seconds? At 20 seconds, that's over here. So what we want to know is we want to know what's the gradient at that point. Now, because this is a straight line segment, we can just find the gradient of this whole line. Okay, and so basically it's risen from 100 meters to 120 meters. That's 2 meters in a time of 16 to 22. 2 meters in 6 seconds. All right, so 2 over 6, that is just 1/3 of a meter per second. Okay, all right, just checking that. It's 20. So it's not 1/3. It's 20. It's not 2. It's 20 over 6. Sorry, 20 over 6, which is 20 over 6 is 3 1/3. That's not 20 over 6. Sorry, 20 over 6 is 3 3 and 1/3 meters per second. And then the average speed between the 10th and the 22nd seconds. All right, so now we're talking about going the average over this time over here. So what we're going to do, we're going to go from here, all right, the 10th and the 22nd. So that's to there. We're going to work out the average gradient of these, of this straight line. Right, so from 20 meters to 120 meters, so 100 meters of gain in 12 seconds. 100 over 12, right? 100 over 12 is the same as 50 over 6. It's the same as 8 and 1/3 meters per second. 8 and 2/3 meters per second. 25 over 3, no, 8 and 1/3. Okay, right. Okay, here's another example, and this one has got to do with a water tank. Pause the video briefly, try it yourselves and see how you go, and then we'll take a look. Okay, so what was the average rate of change? Well, when we talk about the average rate of change over the whole time, we're talking about from this point right across to there. Okay, and what's happened is risen 300 and run across 24. So 300 over 24, and that will be, we're not going to work it out, but that will be liters per hour. Okay, we can write it like that, or we could write it as liters dot h to the -1. And it says, did the volume increase or decrease over that time? And the answer is that it increased. And the reason it increased is because this rate of change, this gradient, this rate of change of water with respect to time is positive. Okay, positive rate of change. I'm just going to write that here with a red pen. Positive rate of change. Okay, we often use a little triangle for a symbol for change. Then it says, what was the average rate of change between the 10th and the 16th hours? Okay, so now we're talking about from here to here. And notice we're putting a straight line in. It's actually not a straight line, it's a curve, but we are going to estimate, we're going to get the average using a straight line, and that's a really important idea. So what happens is it drops down 200. And that's from 10 to 16, so that's in 6 hours. And that's liters per hour, right? And this time it's a decrease. And the reason it's a decrease, all right, is because there's a negative rate of change. Okay, then it says, after how many hours was the tank at its fullest? Well, this is the volume on this axis, so we want to get to where did the graph get to the highest point, and that is in fact over here. All right, it looks to us to be about 6.5 hours. Okay. Okay, right, let's turn over, and now we're going to look at the notion of average gradient. Average gradient is what we've been doing. We're using a straight line to find the gradient between 2 points. Right, so if we find the average gradient of this graph between these 2 points, let's work out what the actual points are. Where x is 0, so this point is 0 something, and this point where x is 2 something. Right, to find the gradient of this dotted line, what we're going to need to do, we're going to need to just use our gradient formula. First thing we're going to need to work out is what are the y values of these points. So if we put 0 into this function, we put 0 where all the x's are, we actually get 3 times 0 squared plus 2, we get 2. If we put 2 in, we get 3 times 2 squared plus 2, and that is 3 times 4, which is 12 plus 2 is 14. Now we're going to use those 2 points to get an average gradient. Really important idea, an average gradient. And what's happened is that we've actually risen 12 in the time that we've run across 2. So our average gradient is 12 over 2 or 6. Okay, we're going to ask you to pause the video and try B and C Okay, and then we'll go over those together, and that'll be the last thing that we do for today. Okay, this time we've got a kind of a parabola that's kind of a sad parabola. We don't know exactly where it is, okay, but an x equals -1, all right? When we put -1 in here, we're going to get -1. Remember, we must square that. We get +1 and then make it negative for that negative. So we actually get -1 plus 1. We actually get 0. So at -1, this graph is at 0. Okay, -1, 0. I'm not sure exactly where we're at here, but maybe over here somewhere. Doesn't really matter about the picture too much. And then at 2, well, when we put 2 in, remember, don't square -2. We're going to square 2. We get 4. -4 plus 1, we actually get -3. So we're looking somewhere like this. Okay, and if we use those 2 points to work out the gradient, then we are finding an average gradient between those 2 points. All right? And so the average gradient is going to be, well, we've dropped down 3 in the time that we've run across 5. So our average gradient, -3 over 5. Okay, all right, and the last one, x squared, we know what x squared is. It looks like it's just a kind of a parabola like that, between x equals -2 and x equals 1. Now, -2 is actually going to be -2. When we square -2, we get 4, and when we square 1, we get 1. So now we're using those 2 points to find an average gradient. And that's the average gradient of that graph between those 2 values. Okay, so our answer is just going to be average gradient. Let's see what's happening here. We've dropped down by 3, and we've run across by 3. So in fact, -1 is our average gradient. Right, we're going to stop there, and we look forward to seeing you next time. Have a great day, everyone.